All right, thank you very much for coming. Before we begin, let me start by introducing myself. My name is Nitesh Danjani, and I have the URL to my blog up there if you are interested in keeping up with what I have to say. I currently work for a corporation in the United States. My job responsibility there is to head their application security practice, and my team also performs network and application level assessments globally. Before that, I was a manager with Ernst & Young. My team performed attack and penetration reviews for our clients. And before that, I was a consultant with Foundstone. Before we get started, let me ask and answer the question, why is application security important? I rarely believe anything that comes out of Gartner on face value, but I think I believe them when they say that most of the attacks today happen at the application layer. You don't have to believe the numbers, 75%, whatever the number is. I think most of us in this room will believe that number is pretty significant. The reasoning for that perhaps is, you take an enterprise level web application or a web service that is exposed to the internet, and let's assume that this application is large in size. You would have anywhere between 500,000 lines of code to 1 million lines of code. So the opportunity in this, in such a large amount of code to do something wrong is pretty big. And if there is a defect in it, even in one line of your code, somebody that has, just has a web browser can have access to your database just from the web browser. And network level controls do nothing to stop application level attacks in most cases. In some cases, they even facilitate the attacks. So with that in mind, and also knowing that the title of my talk is called Breaking and Securing Applications, given the amount of time I have, I don't want to really turn this talk into a methodology on how to hack applications. You'll probably find a lot of books about that. You don't need me to tell you how to do that. But instead what I want to do is concentrate on two high-risk attack vectors, cross-site scripting and cross-site request forgery, to illustrate certain points, to illustrate certain thoughts I've had with the application security industry today and how we can make things better. I'll be the first person to tell you that if we want to assess an application, you really need to do a lot more than just XSS or XSRF. But the reason I'm picking on these two attack vectors is they're common, and they're good guinea pigs to illustrate other points I want to make. And those points are that we need to do a better job of understanding root causes of these high-impact attack vectors. Cross-site scripting is a favorite of mine because I think even in the security industry, people misunderstand what cross-site scripting is. You'll find books and white papers that will tell you that cross-site scripting is an input validation problem. But if you look at the root cause of cross-site scripting, it's output validation, not input validation. We need to do a better job of demonstrating impact of these high-risk attack vectors. I want to go through a case study where I found a XSRF issue in one of Yahoo mobile application, and there is reason why this is a lot more interesting to me, and we'll talk about that. We'll talk about the complexities of assessing for XSS and XSRF. And of course, again, I tell you, I'm picking on these two attack vectors, but when I start talking about complexities and automated tools, I hope what you will take away from this talk is not just XSS or XSRF, but in general, that there are some flavors of attack vectors that automated tools can never find. But at the same time, let's talk about what we can do to make these tools better. We'll talk about how, when you talk about XSRF, it's always fair to mention that XSRF can be abused by an entity that's sitting on the internet to make your web browser, assuming you're on an intranet, perform transactions within the intranet context. And so we'll look at an example of that. And now that we're talking about XSRF and how XSRF is really when a malicious user abuses your browser to make it perform transactions, let's talk about as an application owner, assuming you are an application owner for a business. If there's a vulnerability found in the web browser or components within the web browser, what does that mean to you? Throughout the talk, when I mention assessment tools, I want you to think of two different flavors of application assessment tools. One is the black box assessment tools. So you have vendors like AppScan and Spy that want to sell you their black box assessment tools, where you give it a URL, perhaps a login and a password to an account. It will spider the application, try to find vulnerabilities. But at the same time, I'm also talking about static code analyzers. Companies like Fortify and Ounce Labs want to sell you these products. The reason these products are important is not only because they cost hundreds of thousands of dollars, so you have certain expectations from them, but this is an important topic to me because people in the enterprise rely upon these products for their security needs. I'm a big advocate in the fact that even though we have these great tools, that a human mind should always be involved in an assessment. In fact, I think an automated assessment tool or a code analyzer is only just the first pass of an assessment. So really, like the statement, a fool with the tool is still a fool, right? You could put a dumb person in front of a really good tool, you'll get garbage out. But at the same time, if you can take an assessment tool and make it better, why not? It saves money and it saves resources. And yet again, we'll talk about the complexities of assessing for XSS and XSRF, but these are just two examples. Before I get to the core of the presentation, I want to mention an argument that I sometimes find people in the industry making, and the argument goes something like this. There are people who think that there are types of vulnerabilities that can be parsed for, which is in one bucket, and then you have other types of vulnerabilities that can never be parsed for, that appear to be design-only issues. I think it's a dangerous argument because it stifles innovation. There are at times when you take a look at something and say, well, this looks like a design-only issue or a logic issue. A code analyzer could never find this because of Turing's halting problem or anything like that. Things that assume that appear to be design issues with enough frequency and probability, you can always derive patterns out of them and actually end up parsing them. So a more healthier argument is to say that there are some issues that we know are in the design-only bucket. What can we do to find patterns from them and put them into the bucket that can't be assessed for? So I picked on cross-site scripting and XSRF to illustrate my points because they are extremely high impact and they're popular. Within the web security industry, people will really admit that they're tired of hearing about this cross-site scripting thing. Well, that may be true, but the fact of the matter is that it is extremely common and we must do something about it. Lack of understanding is a big problem. You have a lot of people who think they understand cross-site scripting, but mistake it with input validation. And of course, assessment tools have not caught up. Okay. To show you how popular XSS is, here's Symantec's site that is vulnerable to cross-site scripting. Here is Microsoft sites that's vulnerable to cross-site scripting. Do I think they fixed this? Fox News' site vulnerable to cross-site scripting. I think this is they're still vulnerable. In these situations, what I did is I just popped up an alert box to give you technical proof that there's cross-site scripting. That doesn't do much good if you're sitting with a business owner and executive who's not technical, doesn't need to be technical, and trying to convince him or her why this is a big impact. There's a lot more you can do with XSS than just pop up alert boxes, as in Daniel's presentation. You can steal cookies, lock keystrokes, port scan the intranet, steal browser history, and so on. In order to illustrate the impact of XSS, what I like to do is use a tool called Beef, which is really an XSS proxy. It's extremely similar to Daniel's presentation. In fact, this was the first time I've seen Daniel's talk, so perhaps next time I'll talk about his tool instead of Beef. Beef is extremely similar. In this case, I'm setting up Beef. It's a web application XSS proxy, and saying that when somebody hooks into Beef, show them the word defaced. So what Beef is really doing for me is when I want to demonstrate the impact of XSS, instead of writing my own JavaScript malware, I let Beef do all the hard work. So in this case, I'm saying, show the word defaced. And what I'm going to do is go back to my Fox News example, the URL, and instead of actually injecting my own JavaScript, I'll just inject the URL location to where Beef is installed. Right? And so when the victim clicks on this link, he will see defaced as output by Beef. Now you as an attacker, from the view that you're seeing, will see the victim's IP address pop up as a zombie, and you can get all sorts of wonderful information about the victim, such as the browser information, the operating system, the screen resolution, any applicable cookies, the HTML the user is seeing, as well as, in this case, the keystrokes the user has typed into his browser session and browser history. So if you haven't checked out Beef, I would highly recommend it. So let's going back to the problem of cross-site scripting being an output validation problem. In order to convince you of that, if you're not already convinced, let's take a look at the most simplest CGI script you could ever write. Hello world.cgi takes in a parameter called name. In this case, we have Bob, and it just outputs back Bob, so hello Bob, right? Now let's assume for the first scenario that this CGI script is vulnerable to cross-site scripting. So in order to exploit that, instead of Bob, I would inject HTML code that would have JavaScript in it that would send back my cookie to an attacker. And that's what this would look like. You have the HTML code in for the name parameter that's output back without being escaped, and therefore you have cross-site scripting, right? Fairly simple. The browser looks at this result. The browser doesn't know what's going on. It thinks it's the actual application that's asking it to render this HTML and execute the JavaScript code. Now let's assume a scenario where the CGI script is not vulnerable to cross-site scripting, right? So for the same input, now you have the HTML entities escaped. So if instead of the lesser than sign, the browser sees ampersand LT semicolon. The browser looks at this output and says, instead of actually executing this HTML, this is not HTML, this is text I need to be displaying to the person viewing the website. So in other words, it is during output that when you escape, or if you don't escape, is when cross-site scripting is caused. Therefore, that's my conclusion that cross-site scripting is really an output validation problem, at the root cause, not an input validation problem. Therefore, preventing XSS, HTML escape as much as you can. Unfortunately, even though XSS is really an output validation problem, depending on where you're outputting your dynamic string, you may unfortunately have to do something inelegant as input validation. And the XSSDB website is a pretty good URL you can go to, which has cross-site scripting vectors based on HTML tags, so you can figure out if you really need to be doing input validation in addition to output validation. And of course, a whitelist approach is always the best thing. Persistent XSS is when things start to get complicated and interesting at the same time. The example we looked at before was non-persistent XSS, where you input something and the application echoes it back immediately. Now consider the case where you input a parameter in as a get or post, and the application accepts it and stores it at some data store. It could actually be a database, or it could be a server-side variable. And let's assume a scenario where the application, say you submit a form and you put in some HTML code in there, does not echo it back until some later form shows up, or a different section of the website. That kind of persistent XSS is extremely difficult to find automatically. To think about why, let's assume what would you do if you had to write a black box assessment scanner to find cross-site scripting. You would have a simple algorithm like this, and this is what most of the off-the-shelf application scanners do. You point it to an application, they try to crawl the application, find out what different URLs there are, get a hold of the get and post parameters, and try to fuzz the application with different HTML entities. Then the fuzzer will look back at the result that comes back and says, well, I put in an HTML character here. Did the application escape it or not? Well, if the application did not escape it, I will report it as cross-site scripting. if the application did escape it, let me try some more combinations and permutations before I give up. Works beautifully for non